So in this video, I'm going to talk through synthetic division for polynomials. Now, this video is only going to talk about synthetic division when you are dividing by a linear factor, all right? And that linear factor is very specifically in the form of x minus r or x plus r. So if you'll notice, the coefficient on x here is only 1. There are ways to do synthetic division where you're not dealing with a linear factor and you're not dealing with the x value could have a different coefficient other than 1. That's not what this video is for, okay? So how do you do synthetic division? Well, we're going to start by looking at what we're dividing by, all right? So if you look at example 1, and we are dividing in this case by x plus 5. So what you're going to do is you're just going to focus on the constant term here. The constant term is 5. And whatever that constant term is that you're dividing by, you're going to go ahead and swap its sign. So in this case, it's positive 5, but for our synthetic division, we are going to need a negative 5. All right. If it was negative, you'd swap it to positive. So whatever it is, whatever's attached to x there as that constant, you're going to change its sign. Then we're going to look at what we're dividing into. In this case, x squared plus 6x plus 15. But we're only going to pull the coefficients. So we're going to pull the coefficient of x squared, which is 1. We're going to pull the coefficient of x, which is 6. And the constant term is 15. So we're going to pull that too. So how does synthetic division work? Well, your first step is always going to be the same thing once you've set it up. You're going to take your first term here, this first value, and drop it straight down. All right, so that leading coefficient is not going to change. After this, you begin a process of multiplying, adding, multiplying, adding. So what are we going to multiply? We're going to multiply negative 5 times 1, and so you get negative 5. Now you're going to add vertically. So 6 plus negative 5 is 1. And now you start again. Multiply, add, multiply, add. So we're going to multiply negative 5 times 1, and we get another negative 5 here. Excuse me. And then we're going to add vertically. So 15 plus negative 5 is 10. Okay, your answer is not 1,110. So don't just group it all up, call it done. These answers are your coefficient, your remainder, your constants, but we want to make sure we get them in the right order. So you're actually going to read it from right to left. So the farthest number on the right side, so in this case the 10, this is your remainder, okay? So now if you're going to move one place over to the left, this is your constant term, okay? And then as you move up from the constant, you're going to start telling me that you have powers of x. So this is going to be x to the first. If you had another term here, let's say you had a longer polynomial to start with, you'd start counting up. So you'd have x squared next, then x cubed, x to the fourth, and keep going however long you need to. So let's put this together as an actual answer here so we know what the final answer is. So this is going to be 1 x to the first, which I'm lazy, and I'm just going to write down x. We have a constant of 1. This is a positive 1, so let's go ahead and mark it as plus 1. We have a remainder here of 10. This is positive as well, so plus. Now, how do we deal with the remainders? We're going to write a fractional answer, fractional remainder. So we have 10 divided by, well, whatever we were originally dividing by. So this was x plus 5 to start. So that is the answer to taking x squared plus 6x plus 15 and dividing by x plus 5. So that's how synthetic division works. All right, so again, you just want to focus on the constant of what you're dividing by, but you got to flip its sign. And then you're going to pull just the coefficients here. All right, so we have x squared x, then we have our constant, x squared x, our constant, and just pick the numeric values. All right, let's go ahead and slide on down. I believe there's another one. Ooh, there is. All right, divide using synthetic division. So you can set up the synthetic division a few different ways. A lot of people basically take the division bar and flip it upside down. just to remind themselves they're using synthetic division as opposed to regular long division. So the number that goes in front here is going to be the opposite of what's attached to x here. So when we actually find this answer here, x minus 1 is going to give us a positive 1. And now I want the coefficients of this expression, but we've got to be careful, because if we look at this expression, we have x cubed, we have x squared. We're missing the x term. There is no x term there, so we're going to need a placeholder for it, and then we'll fill in our constant. So x cubed has a coefficient of 1. X squared has a coefficient of 5. X doesn't exist, so we're going to use 0 as a placeholder. And then we have our constant of negative 6. So I'm going to give myself a little line here of space to work. This first value, first coefficient here, drops straight down. And now I'm going to begin that process of multiplying, adding, multiplying, adding. So it's nice when we're multiplying by 1 because not much changes. 1 times 1 is 1. Add vertically, so 5 plus 1 is 6. Multiply, 1 times 6, 6. Add vertically, multiply, add vertically. Now, kind of nice to know. Okay, we're going to start again in terms of identifying these pieces. So this last piece here, this last value, is our remainder. So what this tells me is that this polynomial here has a perfect factor of x minus 1 in it. There's nothing left over, which is kind of nice. All right, if we move one place to the left, we have our constant. One place to the left, we've got our x to the first. You can just write x if you wanted to. And if we move again one place to the left, we're going to move up a power on x's, so this is now x squared. So putting this answer together, we have 1x squared, so x squared if you're going to be lazy, plus, that 6 is positive, so plus 6x. Our constant is 6, and the remainder of 0 means you don't have to add anything because it was a perfect division problem. All right, so that's problem number 2. I'm going to go ahead and slide on down to the other examples. I think it was 3B and 4B. All right. Now, for 3A, we already did this problem using long division. So we know the answer, right? That's not the issue. Let's just show that you get the same answer with synthetic division as you would with long division. So what are we dividing by here? X plus 10. So I'm just going to pull negative 10 as our x value. And then I want to pick up the coefficients of my cubic function here. So x cubed, coefficient of 1. X squared, coefficient of 6. X, coefficient of negative 30. And the constant, of course, that we're going to end with is 102. I'm going to go ahead and slide in on this just a little bit, or tighten up on it so I can get in there and really give myself some room. So we're going to drop that first coefficient 1. We're going to multiply, that's negative 10. Add vertically, multiply, add vertically, multiply, add vertically. Now, you may get to the point with these that you don't need to put the little note to yourself. You could also abbreviate. So this is remainder, this is constant, this is x to the first, this is x squared. And you don't have to do that. It's just a reminder of what those pieces mean, just so you're looking at them right. So if we translate this into an actual mathematical answer here other than 1 minus 4, 10, and 2, we're going to have 1x squared, so x squared, minus 4x to the first, or just 4x, plus 10, and then the remainder we need to write as a fractional remainder. So it's going to be plus 2 over, and remember we're going to put it over what we were originally dividing by, which was x plus 10. So x plus, whoa, wait a minute, that's not an x. So let's do x plus 10 there. Now, there shouldn't be any shock or surprise that this answer is the exact same answer that we got for the long division. I'd be more surprised if I got a different answer. Whether you do long division or synthetic division, you should still get the same answer. It's just a matter of, can you do the synthetic division? Like, can you actually use this linear function here, this linear expression, and divide it? And can you set it up? All right. So I'm going to go ahead and slide on down to 4B to finish out these notes, although it's apparently labeled 4A as well. All right. So what are we dividing by? Well, we're dividing by x minus 3. So if we find that actual 0 there, all right, that turns it into a positive 3. And now I want to get the coefficient to fill in the rest of this. So my coefficient for x cubed is 1. My coefficient for x squared, well, there isn't x squared, so 0 is a placeholder. My coefficient for x, again, there isn't 1, so 0 is the placeholder. And then my constant is going to be negative 20. Little room to work here. First value drops straight down. And again, you then start the multiplication, add. So 3 times 1, 3. Add. 3 times 3 is 9. Add. 3 times 9 is 27. Add. Okay. So 1397 are the values I'm getting here. And again, you don't have to do this next step. It's the reminder of what the pieces mean. So starting from the right, you have your remainder, your constant. This is x to the first, x squared. And then, of course, if you had a longer polynomial, you would keep counting up the powers of x. So let's see what we've got here. We have 1x squared, so x squared it is, plus 3x, right? Those are positive 3s. That's a positive 9 as the constant. And then the remainder is positive 7 over what we were dividing by, so x minus 3. Again, no surprise here that this answer matches what we did in the long division part. It's just a matter of, can you do synthetic or do you have to do long division? And honestly, if you choose to do long division, you can always do that. Synthetic division just has its limitations. So if you have any questions or concerns about either long division or synthetic division, drop me a message and let me know what I can help you with.